Alright, so all you can see here is this is like my board notes, my lesson notes. So basically what I've put under here as board work, put in your notes in your book, just as usual. I've written a few things out already, so just pause the video if you like and write down these integrating inverse trigs. Basically, here's your heading, integrating inverse trig, and there's 6 integrals to remember. But if you look closely, there's really only 3 that you have to remember. The idea is just if you have a value of a rather than just 1 for sine, cos and tan. And the 2 that I have put a red box around are the 2 that you are given on your table of standard integrals. Basically, you're not given cos, but it's really easy to remember cos because it's just a negative version of sine. You're not given the values where a is 1. I kind of think they're irrelevant because this still works when it is 1. But just looking closely, notice that the only one that has 1 over a out the front is the tan. And I still remember that I thought that was a mistake the first time I saw this, but it's not. Only tan has the 1 over a out the front. So pause the video now and get those down. Okay, so from there we look at a nice easy one to start with. It's easy because it's in the form that we wanted already. Look at these 6 formulas and think about which one of these 6 this question belongs to or looks exactly like. And you'll soon realise that it is tan inverse right here. And it's already in the form we need. Everything's perfect. I could go to the extra step, and maybe I would the first few times I do these questions of thinking it like this. Which then you can see is going to just be 1 over 3, lots of tan, minus 1 of x on x on 3 plus c. And that's it. The hardest thing about that easy question is just recognizing when you're in your exam that that's what it is. And not trying to do it by algebra or by logs, just realizing, making it familiar that that's from the table stand integrals and you know how to do it from there. So that's the easiest you can get. Okay, so from there I've got a harder example. Okay. Now, the harder examples, generally you can do with substitution and without. To be honest, with substitution is, in my opinion, easier. However, I am showing you without because a lot of people, like me back in the day, didn't like substitution, and if you could get out of it, I would. So let's start with the without substitution. So when I say without substitution, without using substitution to do the integral. So we know how to integrate by substitution, and this version you don't have to do that. The idea is I want it in the form, straight away I can see that this is a tan. I can see it's a tan because it doesn't have the square root, which is the biggest part about it. So straight away I can see it's tan. If you look back up at tan, think about the form you want it in. You want it as some number squared plus 1x squared. Notice how the coefficient of x is always 1. So what you have to do is rewrite this question now with the coefficient of x squared here being a 1. And to do that, you can see that it's just going to be, if I can factorise out a 4 out the front here, then I will have just 1x squared. But I can't just write 9 here, because if I did expand that out, I'd have 36. So it has to be 9 on 4 in here, because then the 4, when I times it by 9 on 4, would cancel, so you'd get 9. Then 4 times x squared gives you 4x squared. So always double check. It's about manipulating something inside the brackets so that the idea is you want a coefficient of 1. Now, from there, I can bring out a quarter out the front. Now I can see it's now just the integral of 3 on 2 being squared plus x being squared. And now what do you know? It's in the form that we need it. So I can see clearly it's a tan formula now with my quarter at the front, which is 1 over a is 3 on 2, tan minus 1 of x over a. Now I'm just going to clean this up and expand it. That will become 2 on 3, so 2 on 12, which is 1 on 6, tan minus 1 of 2x on 3 plus c. And there's my answer. So the hardest part about that was manipulating the inside of your brackets there. So the idea is you have a coefficient of 1 for x squared. And then it's not too bad. Let me show you how you can do it though, just by making a small substitution. Now, actually before I do that, let me just rewrite this integral what I know it looks like. I know it is really 3 being squared plus 2x being squared. Now remember, we can't just throw this in as x as the integral because it's 2x here. You either need to make the coefficient 1, which is what we did over here, or form a substitution. So what if we let u equal 2x? Now whenever we do a substitution, the step is differentiate u with respect to x will give me 2. If you think back to the topic where we looked at integrating by substitution, we would then rearrange to get dx equals. So we get du on 2 equals dx. Now fill in your substitution. So now we say, well, that's now equal to 1 over 3 being squared plus u being squared, and dx is du on 2. So I've replaced two things here. I've replaced my 2x with my u, because that's what I said it is, and I've replaced my dx with this value here because that's what I worked out it is. Okay, now I can see it's in a form that I want with, although it's not an x, the value in here has a coefficient of 1. Okay, well, what do you know? It's another tan question because it hasn't got the square root. I'm going to bring the 2 out the front as a half. Now I know it's going to be 1 over a tan minus 1 of u on a, which is going to give me, if I redo my substitution, 1 on 6 tan minus 1 of u was 2x, and of course plus c. And what do you know? Look at that. We get the same answer here as we do here. Now, to be honest, it's really your opinion, your personal opinion of what you should do better. If I was to be biased or lenient towards a certain way, as you can see what I've said already, it's going to be the substitution. Why? Is because that's more of a band 6 student. Only because substitution is important to know how to do anyway. It's going to come up, and if you're good at substitution like this, you're going to breeze through any other substitution question. Not only that, it's because there are going to be ones where you have to do substitution, so why not learn it anyway? I mean, by all means, know this way on the left and understand it. And to be honest, back in the day, I would have preferred the one on the left, but understand the substitution more. Generally, if they're going to give you something like this question, in extension 1, they will usually say, find the inverse by letting u equals sine minus 1 of x. In other words, in extension 1, not extension 2, but in extension 1, they would give you the substitution to make. Extension 2, you're on your own. Extension 1, they give it to you. So a HSC question would normally say, integrate this using the substitution u equals. Now, as soon as you get a substitution, differentiate with respect to x. I know the derivative of that is 1 over the square root of 1 minus x squared. Rearrange to get dx equals. If I flip both of these upside down, I'll have dx on du equals the square root of 1 minus x squared. So then dx is equal to the square root of 1 minus x squared du. Alright, so now if I make my substitutions, well, that's going to be just the integral of u on the top of the square root of 1 minus x squared times by dx is the square root of 1 minus x squared du. These can cancel, because remember, the idea is you don't want u's and x's, the x's should cancel. And we get the integral of u du, which is u squared on 2 plus c. Make my substitution, which was sine minus 1 of x, all being squared on 2 plus c. And that's my answer. Okay, hopefully that's all alright so far. Let's have a go at this HSC problem. I'm not quite sure why it's black and red. Now, you can do this by substitution or do this by your rearrangement. So if you like, a good idea, pause the video and give it a go. If you want, put a line down your page and do one of each. So I'm going to put the solution up in a minute, but pause the video and give it a go. Even just do it on a scrap bit of paper, but the best way to learn is to give it a go. Okay, so let's assume that you have finished it now and you didn't be lazy and just keep listening. If that's the case, then pause it now and do it. Okay, now I really hope you have had a go at this question. Let's see what we get. I'm going to do it by substitution. I'm going to say, okay, let's write it in a nicer form. I know that that's really... and say, okay, this here is my issue, so I'm going to make a substitution for it. I'm going to just say let u equal 2x, du with respect to x is 2, dx is equal to du on 2, and make my substitution. So that is equal to 1 over the square root of 7 squared minus u squared du on 2. Oops. Okay, bring my half out the front. Now it's in a form I like, and I know it's going to be the sine. Sine is going to be sine minus 1 of u on 7, which is going to be a half sine minus 1 of 2x on 7 plus c. And there's my answer. Okay, so have a go at your exercises. It's the very last exercise in all of binomial. Let me just see. I think I just said binomial. I meant inverse. It'll be 7 point... Here we go. 7.8. 7.8. And that wraps up the topic. I'm expecting you to find some of these quite challenging, okay? Now, particularly question 15, you can't do just yet until we finish the advanced topic that's next, I'm guessing. But don't stress about it anyway. Please ask me on any that you aren't sure about and we can work together.